For decades, traditional instructional design operated on a simple industrial premise. The goal was to organize objective content and deliver it efficiently. That approach relies on the cold cognition fallacy. It assumes human learning is a purely intellectual exercise, operating entirely independent of a person's emotional state or social environment. When courses are built on this assumption, they suffer from high attrition and low engagement. A curriculum can have perfectly aligned learning objectives, but those objectives are useless if the user abandons the environment. The industry is now correcting this error, shifting away from traditional instructional design and adopting learning experience design, or LXD. LXD acts as an architecture. It intentionally engineers the holistic cognitive, emotional, behavioral, and social states of the user. Delivering content is a mechanical process. Engineering an environment capable of sustaining deep learning requires a completely different set of tools. This diagram maps the 11 highly subjective internal traits a user brings to a digital environment. Empathic design begins by analyzing these specific variables. Look at the age characteristic. The idea of the tech-savvy digital native is a myth that ignores biological reality. Older learners experience a measurable reduction in working memory capacity. They require more time to process novel interfaces and quickly hit a ceiling of information overload. Younger learners, conversely, lack fully developed executive functions. They struggle with spatial tasks and frequently fail to navigate complex virtual spaces efficiently. We see similar discrepancies in the trait of perceived self-knowledge or calibration. Online learners consistently hold overly optimistic and miscalibrated views of their own progress. They assume they have mastered material when they haven't. Users naturally misjudge their abilities and face strict biological processing limits. Therefore, the digital course environment must be engineered to provide the external regulation the learner lacks. Those 11 subjective traits collapse inward, dictating how a user processes information across 4 specific internal dimensions. In the cognitive dimension, achieving deep learning requires the user to break down and expand their existing mental schemas to accommodate complex new concepts. This creates a psychological paradox. Deep cognitive learning is rarely enjoyable in the moment. It is inherently uncomfortable. Researchers utilize a tactic known as deliberately designed confusion. By introducing short-term frustration, designers force learners to exert maximum cognitive effort to resolve the problem. Eliminate that friction, and you are left with shallow learning. The user might enjoy memorizing basic facts, but they fail to alter their long-term memory or gain conceptual understanding. If a designer ignores the emotional axis, they lose the ability to trigger the friction required for the cognitive axis to function. How do we build an objective digital structure that accommodates these invisible, subjective internal dimensions? This framework illustrates the solution: an outer structural layer wrapping the internal dimensions. It identifies 5 external aspects: course structure and interface, content interactions, learning activities, social interactions, and assessments and feedback. These 5 elements are the only physical touchpoints the designer actually controls. In conventional design, these aspects are often left as default text lists inside a learning management system. This forces the learner to expend cognitive energy just to navigate the structure, diverting precious mental resources away from the actual content. Every one of these 5 external aspects must be custom engineered to trigger a specific combination of the 4 internal dimensions. This isolated section shows the course structure and interface, which serves as the visual stage for all interactions. Human-computer interaction research reveals a direct link between aesthetics and user performance. At a biological level, an attractive, intuitive interface produces positive visceral emotions. This chart illustrates that relationship. Those positive emotions literally increase a learner's cognitive tolerance. They become highly resilient to minor technical difficulties and possess the stamina to endure complex tasks. Graphic design in LXD is an active psychological lever that buys the user essential cognitive bandwidth. Now look at the social interactions aspect. Digital spaces naturally create a sensory void and a high transactional distance between users. To bridge this gap, designers apply the community of inquiry model. The goal is to establish co-presence, the engineered illusion of being together in a shared physical space. Social presence is a strict requirement for driving cognitive presence. Without it, intellectual curiosity degrades. Instructor immediacy and peer connection act as mandatory structural safeguards to prevent behavioral drop-off. A common failure point in online education is fragmentation. Modules, quizzes, and forums are presented as entirely disconnected silos. To solve this, designers utilize pedagogical wrappers. Wrappers are explicitly designed narrative and contextual layers. They interweave disparate content units into a singular, cohesive mission. By framing the material around a real-world scenario, wrappers force the learner to engage their cognitive, emotional, and behavioral dimensions simultaneously. True learning experience design is measured by the continuous state of flow generated by these interconnected elements. This framework translates subjective human messiness into objective digital architecture. Successful design operates from the inside out, beginning with sensitivity to the cognitive limits and psychological traits identified in our analysis. Balancing the external aspects against the internal dimensions prevents cognitive overload and sustains motivation. By abandoning cold cognition, designers move past simply delivering static content to engineering transformative psychological environments.